Diesel engine runaway is a rare condition affecting diesel engines, in which the engine draws extra fuel from an unintended source and overspeeds at higher and higher RPM until destroyed by mechanical failure or bearing seizure through lack of lubrication. Causes: a gasoline engine equipped with a carburetor employs a butterfly valve, controlled by the throttle mechanism, to control the volume of air taken into the engine to control engine speed. A diesel engine's speed is controlled by varying the amount of fuel supplied to the cylinders. In many vehicles, a crankcase breather pipe feeds into the air intake to vent the crankcase without releasing more hydrocarbon vapors into the atmosphere. In a highly worn engine, gases can blow past the sides of the pistons and into the crankcase, creating excess oil mist, which is then drawn from the crankcase into the air intake via the breather. A diesel engine will readily burn this oil mist as fuel, since engine oil has similar energy content and combustion properties as diesel fuel. The extra fuel causes the engine revolutions to increase, causing still more oil mist to be forced out of the crankcase and into the engine, and a positive feedback loop is created. The engine quickly reaches a point where it is generating so much fuel from its own crankcase oil that it can sustain operation even with the normal fuel supply shut off, and it will run faster and faster until it is destroyed. A runaway condition can also result from oil supply by failure of the oil seals in a turbocharged diesel engine, from overfilling the crankcase with oil, or certain other mechanical problems such as a broken internal fuel pipe or a worn or incorrectly assembled throttle linkage. In vehicles or installations that use both diesel engines and bottled gas or operate in an area where vapors may accumulate, a gas leak drawn back into the engine air intake can supply unintended fuel. Diesel engines being used in industrial environments are subject to external hydrocarbons being introduced into the atmosphere and then being sucked into the air intake systems. This dangerous situation occurs at chemical plants, refineries, drilling sites or any environment where hydrocarbons are being produced. The BP Texas City facility was destroyed when this occurred in 2005. Federal law mandates the use of air shutoff valves or ESD valves on diesel engines used on offshore drilling rigs. Several ways to stop a runaway diesel engine are to block off the air intake either physically using a cover or plug, or alternatively by directing a CO2 fire extinguisher into the air intake to smother the engine. Engines fitted with a decompressor can also be stopped by operating the decompressor, and in a vehicle with a manual transmission it is sometimes possible to stop the engine by engaging a high gear, with foot brake and parking brake fully applied, and letting out the clutch quickly to slow the engine RPM to a stop, without moving the vehicle. Notes. References: Seifert, Bill. William G. Seifert. Daniel Spur. Offshore Sailing, 200 Essential Passage Making Tips. McGraw-Hill Professional. ISBN 0-07-137424-8. See also, Overspeed, Rev Limiter. External links: a General Electric ES44AC locomotive in the process of a runaway, Norfolk Southern diesel locomotive in runaway.